Okay, if you haven't watched parts 1 and 2 of this series, make sure you go back and watch those. All right, now we're taking the cube root of 1. So we now know from the other videos that all numbers have lengths and angles associated with them. And when you multiply them, you multiply the lengths and you add the angles. So here we go. Cube root of 1, I'm looking for a number so that when I do 1 times 1 times 1, I get 1, and 0 plus 0 plus 0, I get 0, because 1 is really 1 at an angle of 0. Okay, so we're cool. That's right there. All right, that would be my answer. Length of 1 at an angle of 0. And that's pretty much what everybody would have picked. But now that you know a little bit more about complex numbers, you can go a little further with this, right? I still know that 1 times 1 times 1 is equal to the 1 I want. But now if I do 120 and 120 and 120, because I'm not stuck with 0 and 180 anymore, I can get a number over here, about 120 degrees would be right about there, right? So that angle would be 120. And what does that mean? Well, if I do 1 times 1 times 1, I get my 1. But if I do 120 plus 120 plus 120, I don't get 0, but I get 360. But that's in the same spot, just as good, okay? But also, let's do it again. 1 times 1 times 1 is still the 1 I want. But another angle that's going to work is 240. 240 and 240. And that would be down here, right? So that these would all have a length of 1. But now this one has an angle of 240, which goes all the way around to there. And if I tally it up, 240 plus 240 plus 240, that's 720. But that's just two 360s, but that still puts me in the same spot. So all of these numbers, when I multiply them together, I end up getting 1 at 0. Now I want you to notice one other thing before I move along. If you connect the tips of all these numbers, you end up getting an equilateral triangle. Also notice the angle between all of them is 120, which happens to be 360 divided by 3. So don't forget, that little cube root has a lot more meaning than you thought it did. Do you think it was a coincidence that the roots lie on an equilateral triangle? I don't know. I guess we'll have to see.